All right, so last time we did polynomial functions. This time, guys, what we're going to do is trig functions. Lucky for you guys, we only really need to do 2 of them, right? We're really just going to do sine and cosine, so it's super easy. So what this will be is a few sine and cosine mixed in with a few from last time, all right? So let's take a look at it quickly. That way then you guys can work on the practice as well as making your corrections to the test in case you need to be redoing that. All right, so bell work. Who did the bell work? Nobody. No, just kidding. Somebody did it. Who did it? Yeah, you did, because you are that good student. Prove Juanita wrong.
It is 2x3 minus 1.
So, but remember we have to add one. We're adding one. So it should be 2x to the power of 4 over what? Over 4 plus 4x, maxo. And then I can simplify it, right? So what would this become? 1/2. So x to the 4th over 2 or 1/2 times, doesn't matter, plus 4x plus c. There we go. Good reminder of last class. But of course, Mata doesn't need that reminder because she already knows it. Yeah, she's taking AP next year. Come on, I've convinced Marco. I just got to convince you now. I heard Emiliano's going to take it too. Are you taking AP? Ah, see, I was right. Carolina, are you taking it?
Yeah.
Nah, see, there we go. Matas, they're all taking it. What about you?
I can make my friend Elena.
Elena's taking AP already. She already decided. Ah, sorry. Well, Elena's coming to AP. Alrighty. The next one, we've got some weird looking exponents, but it doesn't change the way we do it, right? So, Martin, what happens if I've got 4x to the negative 3 and I add 1 to the exponent? What does it become?
-2.
Yeah. And then we divide by that new exponent. Now, this one, don't get alarmed. What is the square root of x? What's that as an exponent? 1/2. So this is really 2x. If it was to the 1/2 and we add 1, 3/2, exactly. And then this is the part that's kind of awkward. So remember, if we're dividing by a fraction, what does that really mean? Multiply by the reciprocal. So I'm going to flip it to become 2/3 and multiply. That was the shortcut we talked about last class. And then, of course, plus c. Last thing I need to do is simplify these. Jose, what's 4 divided by -2?
2 divided 1 or 2.
Yep, exactly. And we can just write that as 2. We don't have to write it over 1. It's not wrong, but we just write it as 2. And then if there's one negative, it stays negative. So 2x to the -2 plus, can't do anything to this one, 2x to the 3. Oh, sorry, yes I can. What am I doing? I'm crazy. So now I've got 2 and 2/3. How do I multiply fractions? And that's for adding and subtracting. It's not wrong, but it's way more work. So let's not do it. I actually don't even need to cross it. It's even easier, you guys. This is where we just multiply numerators. So 2 times 2. And then multiply the denominators 1 times 3. Okay? Any of the other ways that you guys just said, it's not necessarily wrong. It's just more work. So don't do it. But it won't be wrong if you end up doing it. Matas and Maxo, my God. Maxo and Matas, I'm about to make you guys hold hands and take a walk.
No, sir, no.
And stop talking. Alrighty. So, remember that the antiderivative or the integral is just the opposite of taking the derivative. So, we learned earlier that the derivative of sine was cos, and the derivative of cos was negative sine. So, similarly, write what the antiderivatives you think they would be. So, if I had cosine, and I need to go backwards, so I'm going like this direction, what would it be? What's the antiderivative? Exactly, it's just sine. Now, the next one's where we got to think a little bit. If I have the antiderivative of sine and I'm going backwards, I would get cosine. But if this is negative, what does the other one need to be? Negative as well, exactly. So it's going to be negative cosine of x. Technically, plus c. Technically. But in this case, we're just trying to remember or learn what those two are. So, not overly hard. It's not written on the wall, you guys, but the opposite is written. So remember back there, we've got like the derivative of sine is cos. And if we're taking the antiderivative, we just need to think about the fact that we're going backwards. Okay? Alrighty. So let's give that a try then. If I've got the integral of 2 sine, does the 2 change anything or does it just stay out front? It just stays up front. We could actually rewrite this like this and just treat it like a spectator. Be like, hey, it's just watching what's going on. Okay? So then it's going to be 2. So not negative because remember we're starting with sine. Oh, sorry. Yeah, we're integrating sine, so it is negative. My bad. Yes, you're right. Cosine of x. Now, does it matter if I put the negative in the front or in the middle? Technically not. Why do you think I might put it in the front like that then? Why would I choose to do that? Maxo? Kind of, so it's just a single term, exactly, right? It's just negative 2 cosine x. The problem is, you guys, if you write 2 times negative cosine of x, some of you will think it's 2 minus, and it's not. It's not the same thing. They are multiplied together, okay? So that's why I like to move the negatives to the very front. All right, so this next one, doesn't matter that there's 2 of them, right? So this one, if we go backwards from cosine, what are we going to get? So the antiderivative of cosine is? Yeah. And the antiderivative of sine is? Negative. So again, I'm going to put that in front. So it's just rather than plus negative cos, I'm just going to say minus cosine of x. And as always, there could be some constant that disappeared. So we need to say that it could be there. Okay? All right, I want you guys to try that next one on your own. Nah, you can do it. So I'm going to write it, but I want you guys to try and do it on your own. Just look up when you're done. Tomas, do it on your own, man. Once you're done, check. Make sure that's what you got. Don't just copy it, Matas. Did you try it on your own? Did you get it? Good work. See, it's not so bad.
Nobody gets it.
It gets worse. It really doesn't, actually. It honestly doesn't.
Yeah, because
All right. It doesn't, I promise. It's not that bad. Any questions? No? All right. Awesome. Mariana, the notes are right there, okay? They say 4.1, but they should say 4.2. I just had the title wrong, so you can change it. All right. So this is just combining what we did last class with what we're doing this class. So, if I'm taking the integral of t squared, what does that become, Marco? T becomes what? Instead of t squared, it's not 4. Cubed. We've got to add 1 to the exponent, and then we divide by that new exponent. And if I had sine, what does that become? Exactly. The negative won't change anything, so it's just... actually, hang on. No, it does change it, right? Because it would be positive, yeah. No, it should be t. It should be t, man. That's my bad. Yeah, it should be t. We shouldn't change the variable. Now, remember, before we move on here, one of the ways that we can kind of check it real quick, and like the reason I realized, no, that was wrong, right, is we can just take the derivative. So if I take the derivative of this thing, I would get 3t squared over 3 minus sine of t. Is that what I started with?
Yes.
Yes. It's just got these 3's, but of course they cancel. And so my check tells me, hey, I did it right. You don't have to do it all the time, and you don't need to write it down, but you should probably think about it at least in your head to be like, yeah, I did it. Okay? Especially with the sine and cosine, just because you want to make sure you don't mess up the negative. All right, try that next one, guys. Again, I'm going to write down the answer, but I want you guys to do it on your own. What up?
Are we going to have another somebody?
Oh, absolutely. I think there's 2.
And are they examples?
One of them.
Whoosh.
Of these, of the antiderivative.
Yeah. But this is easy. It's easy. The thing is, guys, in regular calc, we don't do very difficult antiderivatives, so it's pretty easy.
We should do like an interactive.
We'll do either an activity or an interactive one.
No more tests.
We'll see.
Sir.
I told you what. No, I didn't. We will do something else in addition to it. What? There you go. Anybody have any questions about that one? Did you guys get it? Elena? Did you get it or did you cheat and copy? Good, don't cheat. Don't cheat. All right, guys, listen. If you go directly from here to here, because you can see that 4x squared over 2 is 2x squared, nothing wrong with that. I do not care if you skip this step where you show that it's 4 over 2 and go straight to the 2. Okay, so whatever is more easy or comfortable for you, do that one. Okay, don't try to do it in your head if you're going to make mistakes, but if you're confident, oh yeah, I can do that simple math, go ahead. Not a big deal. Square roots are not impossible. What are you talking about, girl? So, first thing we're going to do on that next one is we're going to rewrite it then, so that we don't make Luciana panic, right? Let's get rid of her panic. So this would be the integral of x to the 1/2 plus sine of x dx. Because what happens when I add 1 to 1/2? What do I get? 3/2. We're just adding 1. We're not adding, right? So 3/2. And then what do I do if I'm dividing by 3/2? Multiply by 2/3. Right? It's the same thing as dividing by 3/2, so it's easier to just quickly do the multiplication. All right, and then what's the integral of sine? Negative cosine. You see how it's not that bad? Do you see? Even with a square root. That's it. That's all we can do. I can't do anything else. All right, guys, try the next one on your own. Again, I will write down the answer, but I want you to try and do it on your own. Okay? All right, that should be what you get. Check and make sure once you're done. See that you got that. And again, if you want to skip that division, that's totally fine. If you can just do it in your head, not a big deal. Yeah. If you can't, write it down. It's all good. All good. Any questions about it, or does it make sense? Yeah, we're good? Nico? All right. Oh my gosh, it's got so crazy. No, it's not that bad, I promise. All right, first thing we're going to do is we're going to rewrite it. So if I have the cubed root of x, what is that as a exponent? 1/3. Then the 2 sine x doesn't change. Now, this one does change. What is the 4th root? So the cube stays as cubed, exactly, and then the 4th root becomes the over 4. So all we're doing is rewriting it with those fractional exponents because it makes our life a lot easier, right? So now, if I've got this one, I'm going to go x. If I add 1 to a third, what do I get? 4/3. If I'm dividing by 4/3, that's the same as multiplying by 3/4. Right? I just flip it.
4/3.
Yeah. So if you're not sure, do it on the side or with your calculator, right? 1/3 plus 1 is the same as 1/3 plus 3/3, right? Because I just changed the 1 into 3/3, which is 4/3. So that's how I get it, okay? Now, next part here is going to be, should be minus 2 cosine of x. What happens when I add 1 to 3/4? Yeah, right? So 3/4 plus, instead of 1, we write it as 4 over 4. And that's where we get our 7/4. So it's going to be x to the 7 over 4. If we're dividing by 7/4, what's that the same as, Emilio? If you Alrighty, so yeah, it was the same as multiplying by 4/7. And then our last one here just becomes sine of x. What's the very last thing I always got to put on? Plus c. Look at that. See, not that bad, right? It looked scary, but it's not. Try the next one on your own. Similar idea. Okay? So start by rewriting it. Okay, we're going to start by rewriting this one. Well, since it's rewritten, I want you guys to try it on your own. Mariana, put your phone on the wall. No. Stop texting whatever his name is. Or her name, whatever. Manas, what'd you get? Yeah, you heard me. Remember how you were supposed to see how, oh wait, this one isn't a you try. I forgot to write the you try on this one. It was supposed to say you try, but anyways. What is it? So 2/5 plus 5 over 5 is what? No, you're right. So what is that? 2/5 plus 5/5 is what? 7 over 5. And you're right, yes. So it does become 5 over 7.
What?
I didn't realize you were saying this part first. Isn't that what you said? 5 times x? Yeah. So I'm pretty sure she did. Maxo, what did you say? Nothing. Anyways, okay. What's the next one here? There we go. Good. Minus 4 cosine of x. And then this one, plus or minus 3? Plus 3 sine of x. And, of course, plus c. Look at that. And then you get some practice. We are done. You got like 35 minutes to do that practice. Wow.